Welcome to another session for this Global Hack Week featuring API Week. I'm finally back for the part two of building your own API using FastAPI and ngrok for AI. So during this stream, we have a lot of things to get done as we are going to get our hands on in some hardware simulators and also finishing our API that we were building using FastAPI, and then we used ngrok to publish that API so anyone could actually access it. So before I get started and start continuing with our stream, please don't forget to check in on the link that I've shared on the chat. That's to make sure that you are getting your points for assisting to this live stream session. Yeah. So yesterday we had a lot going on. There were plenty of streams, and I was very happy to give so many sessions on this as well. And luckily for today, we had a little break from part one until part two, which is right now. So yes, I will give like a brief intro on like what we saw in the part one, so we don't actually get lost if this is the first time that you're entering the stream and you were not able to be for the part one of the stream. Then I will also be giving a recap. Awesome. So this was the size share that I had yesterday, and before I say anything else, I just want to introduce myself. So some of you already know me because I've been giving plenty of streams lately. My name is Jocelyn, and I'm a coach here at Major League Hacking. I enjoy doing salsa dancing in my free time, which hopefully I will have more free time this semester. Hoping to. I like to collect Minecraft bee plushies. It's something that I really enjoy, and I also go super crazy when I see like a bee plushie because I like them so much. I just recently watched the Minecraft movie, and it was okay. I wouldn't say I got disappointed, but I was expecting a little bit more. That's all I will say for today. I also enjoy robotics. That's why, and I study that at university. So that's why I always like to bring some hardware hacks or some hardware projects into the live stream so we can actually get our hands on that. And also recently, we a new streamer joined, Charvel. So he also studies robotics, and he also likes to do streams about like robotic operative system and also like using hardware components, which is super cool. I hope he does more streams for hardware because we need more. We definitely need more hardware hacks, especially for hackathon projects that are becoming very popular lately. Awesome. So I'm not going to go through the whole slides that we saw on the part one, but I will explain like some basic things. I'm hoping that by now, after seeing like so many streams or attending like some of the past Global Hack Week sessions, we all have kind of like a notion of what an API is. If you don't, then feel free to ask in the chat. I will be reviewing that as well. So this is where I wanted to get to. So we're going to be using this tool called FastAPI. And this tool will basically allow us to create our own API so we can actually like post and get information from our data or our database or wherever we want to fetch like our data. So just to keep in mind that this is not the only tool that it's out there like for creating APIs. There are more tools. I just like to use this one because it automatically generates you like documentation for your web service. So that's why it's super cool. And I will show you why I meant by that. There's also another popular one that's called Flask. That one is also for like Python applications, which is also pretty cool. I used to use Flask quite often, but now I just moved on to FastAPI, and I can't stop using it because it's super intuitive and I like the documentation very much. So this is what we did on the last session. We basically ran our first FastAPI application, and I'm gonna do that again, like to run the code that it's on the repository, just to make sure that everyone is getting that application running, because it will be basically like the basics for our project. So it's like super important. What else? After that, we basically run a simple ngrok server. So we basically run this code and everything was working smoothly. And then I explained basically how you can create APIs, because sometimes you want like a specific data to be published, or you want like a specific use cases, then that's when you would need the use of your own custom API. Then I explained what ngrok is. Ngrok is basically a cross-platform application that allows you to expose your local web server into the internet. And the meaning on why we want to do this is to make sure that we have our application running up on the network, and we can actually access it from the internet. Because if we only use the FastAPI server, then that will be on localhost, running on a port in our computer, and only you will be able to access that information. But once we pass on through a tunnel of ngrok, we are actually able to publish that information into the internet, so more people can actually use our own API. So that's just basically how it works. What else is important? Yeah, this is basically just architecture. Nothing so hard to understand here. Just basically, ngrok takes your local address, passes it through an ngrok tunnel, and then publishes up into their ngrok servers, and then you're able to host your API online. Awesome. So this was basically just the end of what we did on session 1, I'm sorry. And for session 2, I'm going to share again for the people who are new to this part 2. I'm going to share on the GitHub repository where we were working the code for the past session. It was nothing too complicated. It was just basically running like a hello world in our FastAPI server. So it was pretty straightforward. I will share this thing with you on the chat. There we go. So now I'm actually going to share with you what we were working like on the past session. So let me just share a new screen so you can see where the repository is and how to actually get access to all of the code that's running there. There we go. Let me just, awesome. So let me just open a new browser tab so I can get a look into the GitHub repository that we were working. So GitHub, and then I'm going to search for the repository that I just shared with you on the chat. And let's see if we can get it running again to actually start where we ended on the last session. So over here you will basically find the code for the session that we did the other time, which is on main.py. If you enter this file, just basically a simple API. It's just the default method that says message hello world. And in the README, you can basically find the slides for the workshop, and you can also find the YouTube recordings, which I will be uploading. And in case I forget, then you can also access them on the YouTube channel as well. Great. So I'm basically going to open this on my own VS Code. So let me just open a new how do you call it? A new VS Code tab so you can actually see the same code. There we go. And let me make this bigger. Make this bigger so you can all actually see it. Over here, this is just basically the root of the application. And to run your application, all you need to do is pass API run and then main.py. Wait, is this correct? Let me actually verify on the documentation super quick. FastAPI docs. Let me share that as well while I'm looking for it. So FastAPI. Let me see. Perhaps in Learn user guide. Oh, there it is. First API dev and then the name of the file. So it's FastAPI and then dev and then main.py. So this will basically get our API running, and let's keep in mind that this is only a local host, so it is hosted on port 8000 on our computer. So if we were actually trying to use this API for, like, I don't know, like a project where we want more people to interact with it, then they won't be able to do so because this API, it's only available in your local computer. So if we actually open this on a browser, let's see. So this is hosted on a local port, and you can get just the nice documentation that FastAPI automatically generates for you with all of like the methods, and then you actually get like the schema for each of this. So you can actually like try it out. If I click on execute, just give me one moment. Great. So in here, this is just basically like a hello world. So I'm just basically getting what I have on my actual code, which is this one over here. So over here, I'm just basically running like a simple get method. And I can just like do another. And instead of a get, I can also do like a post and so on. So what we did on the last session is that if we actually want to publish this API into the internet so like more people can actually use it, then I will need to do like a new terminal and then start an ngrok server on that port. So to do that, you need to do ngrok and then http and then the number of the port where you want your server running. So I click on there. Oh, I think I have another server running. Let me shut this one. There it is. And now I can run it again. And now we can see it up and running. And I can actually share this link with you all, and you will be able to access the documentation over there. There it is. So now if you actually enter that link, you will be directed into the API that it's hosted now on the internet. So like literally anyone can have access to it. So if I were to enter this link, let me open it. Oh, why is it open? There it is. And then you click like on best site, and then you will be directed like to the main app. But if you want to have like the nice view, you can just write docs like at the end, and you will be directed like to the nice view. And now you can actually see and do like exactly the same thing that I was doing, but this time hosted on the internet. So this is where we basically ended on our last session. And now as for the content of today, I want us to actually I will try for us to finish in time, and let's see if time doesn't go by super fast. But I basically brought like some hardware with me, and I will also be showing how to do this on an online simulator, so you can also like follow along and not only be left out because you don't have like any hardware at home. So we will be basically using like this simulator online, where you will be able to simulate like if you have like your own hardware, and we are going to try to make that hardware connect with our API. So on the API, we can actually fetch the data of some like sensors or of some hardware that we have connected into our computer. And then hopefully we have time, we can implement that into a Streamlit dashboard. So this will either go on two ways. So the first way is that everything goes super smoothly and we are able to connect everything like super good and smoothly, and we have time to actually develop our Streamlit dashboard. But if we are not able to actually connect everything successfully and in time, then I will pause what we're doing, and we're going to kind of like use like a sample database that has like sensor values that we can like literally generate like with ChatGPT or something, and we can connect to that like simulated database on our Streamlit dashboard. So both sides we were going to be able to create our own fast API methods so we can use our own API. Great. So let's get started with with the brief material that I brought for you all today. So we're going to start using this microcontroller. It is called ESP32, and this is just basically a microcontroller that allows you to work with Wi-Fi and Bluetooth communication. This is very commonly used with Internet of Things projects, such as like smart homes or wearables, or even like in school projects where you can basically use this board in order to publish your data through an internet connection. It basically supports multiple frameworks. The most common one is Arduino because, well, most of developers are familiar with Arduino, but you can also code with it using MicroPython, which is kind of like a variation of Python. It's very similar, but it's just called like MicroPython because it's for microcontrollers. This is a nice dev board. I actually have one over here. I'm going to try opening this so you can actually see it like live. What else is there to see? So the cool thing about ESP32s is that you can actually you can connect them through the internet, and the way that this works is that you can basically interact with RESTful APIs. So RESTful APIs is what we've been working all day long. So it's basically the APIs that allow you to send a request and receive a response. So these requests can be in the format of get, post, put, or delete. And we can basically like fetch data, or we can post data, we can update it, or we can delete it from our database. So a simple example is that you can basically fetch weather data and send sensor recordings to a server. So how this will work is that with our ESP32, we will have like a temperature sensor connected, and that temperature sensor will be basically just reading the temperature of our environment. And then on our ESP32, it's basically going to connect through an internet connection using an API, which in this case can be like an ngrok server. And that ngrok server will be communicating in a unidirectional path where we can actually display the sensor data in a nice dashboard. So I know all of this sounds like kind of like too hard to do. I'm just going to tell you that it's not very hard to actually make this work. What's hard is to actually not have any issues with like the Wi-Fi connection, or perhaps that the connection is not like communicating properly. Because you can basically have your code on the microcontroller part that actually, I don't know, like reads temperature data from your environment, and then you can have your api that actually like works, and you can open it and you can see it, and it is working properly. But once that you try to like put both of them like together, it's when things can start to be a little bit tricky, and that's where you need to invest like more time to actually see what's going on. And sometimes it can be like perhaps your model is not working correctly, or like your sensor is not giving the correct values. I don't know. There are like many things that can go wrong over there. That's why it is important that you test it on a simulator first before actually going into actual hardware in there. So this is just like a simple example about what I mentioned earlier about if you want to publish weather data. So the first thing that you will need to do in order to use an ESP32 is your Wi-Fi setup. So you actually need an internet connection in order to use like your dev board. Then you will need to create an HTTP client which will be sending and receiving data. It can be the client on Arduino, or there are even more than you can actually use. And finally, you need to do the API integration, which will be posting the JSON data, or will be fetching the JSON data on the responses. On our case, the API integration will be our FastAPI, which is the one that we've been developing all along. And our server will be the ngrok server that will be basically hosted like on the internet. This is just an example. So in here, we actually import the HTTP client. Then we initialize an HTTP connection into this URL, which is our API URL. And then we generate our get method, as we saw the different HTTP methods that are out there. And one of them is the get. And then we actually send our payload, which is the one that we want to get. And in this case is get string. So this is just like super simple case scenario. It can get a little bit more complex once you have like more data that you want to read, or if your sensor is not giving like the proper data that you would expect, then that's when things will be actually getting a little bit messy. But don't worry. I mean, for simple implementations, we shouldn't have any issue over there. So for this stream, we will be using this tool called Wowkey. This is just basically an online simulator for ESP32, Arduino, and other microcontrollers. You can actually use like different dev boards over there that are kind of like easy to set up. And the cool thing about Wowkey is that it actually lets you have like the hardware on the side and then the code on the other side. So you can actually see like both things working like in real time, and it's super cool. Also, a nice thing that I just discovered recently is that you can actually run like Wi-Fi simulations. So in case that you don't want to connect to the Wi-Fi of your home, like to your physical microcontroller, you can use Wowkey's Wi-Fi simulation to actually getting it up and running. So this is actually helpful if we want to just like test something before we actually do like the real deployment. It will then work like super seamlessly and perfectly. So being that said, I will share the link on the chat for the Wowkey page, where I will need you to create an account before we actually proceed with the next part of the session. So I will give you like a short 3-minute break so you can start creating your account on Wowkey, and I will be back once everyone has created your free accounts. Great. I think we've all created our accounts on Wowkey, so I think we should be good to go. So this is basically what you should all be seeing, which is kind of like the Wowkey main page. And there are like different microcontrollers that you can actually select from here. I have to admit, Arduino is kind of like the most common one because it's perfect like for beginners, and it has different supports like Arduino Uno, Arduino Mega, and also Arduino Nano. We also have the Raspberry Pi Pico. This one is also kind of like common because it supports like other different frameworks that you can use over there. And what else? And we have like some example projects that you can actually run. We could actually try this one out because it's very similar to what we are trying to do. Yeah. And then we have STM32. This one says it's a more advanced board that actually allows you to code in like low-level languages. For example, C. When you actually like manage the computer registers and everything like in there, then that's also like super nice. I'm actually using this at school, and it's very. I would say it's challenging. But in our case, we will be using the ESP32. So if we go ahead and click on ESP32 simulator, we will be able to find like multiple examples, and we can actually try running some of these, and I could walk you through what the code actually means. Yeah, and then we have other versions of the ESP32 like the Xiao, which is another famous one microcontroller. But in our case, we will be trying this first example, which is called Wi-Fi scanning. So if we will actually click over here and see what the code is basically doing, it is just basically scanning the number of networks that we have, that our ESP has like available to connect to. So on this example, as it is like a simulator, it will only give us like the Wowkey network. But if you were actually literally running like this example from your like direct microcontroller, you should be getting like all of the networks that are like in your house or like in your university or like wherever you are located in. And I can actually try that, like connecting my own. Wait like connecting my own ESP, so we can actually see like the networks that are available, like where I am currently at. But that's just if we have like some free time, yes. So let me try running this simulation. It would just be initializing Wi-Fi, and then it is actually scanning like the Wi-Fi networks that are available over there. So over here, it just basically told me that one network was found, and that network is basically called Wowkey Guest. So this is the network that we will be using for all of our projects that we were basically going to be building in our simulator. So if I actually try to stop this and I open up a new instance, ESP32, and then perhaps I can try the ESP32 HTTP server, which is much more similar to what we're doing right now. It says to test, you need the Wowkey IoT gateway as explained here. Then start a simulation and open your local host on this board. And we need a subscription. Let's see if we can actually try it without the subscription to see if we can get it running. So this circuit just basically has two LEDs, and the LEDs are connected to pin 26 and pin 27 as declared over here. This is just basically like a nice interface for the web server demo, which is written like in HTML. And then on my setup over here, I have the declaration of my Wi-Fi, which I'm passing the name of the network, the password, and then the Wi-Fi channel, which is a very specific configuration for, how do you call it, for Wowkey Wi-Fi connections. Then in here, I'm just verified that I'm actually connected into the network that I want. And once my internet connection is successful, then I can create my first state for HTTP, which is just basically doing these. So you either turn the LED on or turn the LED off. So how would you do that? You can turn on the LED 1 depending on the LED state, either if it is LED 1 or LED 2. And the state is just basically high or low in Arduino, for example, which we basically declared over here, which in this case is false. So it means that it will be turned off depending of what we send it on our ESP32 web server. So let's try running these, and hopefully we won't get any kind of like blockers for the thing that says like Wowkey Club subscription. So in here, it says connecting to Wi-Fi Wowkey guest connected. So that's successful. And then this is my IP address, or at least the IP address of the microcontroller or the network where the Wowkey internet connection is. And then it says that the HTTP server was successfully initiated. So let's try going into the local host over here. It says that we can't reach that page. Probably because I actually need this. Let's try going into the test example, see if we can find some guidance over there. Oh, download the latest version from the Wowkey IoT Gateway release page, and then I have to execute that. Oh, I actually have to have like the server running. Okay, well, I can do that. I mean, it's not mandatory that you do it in case you don't want to like download anything. I would just do it like for fun. So we can see if this is actually like running. Where is it? If you're worried running it, you're invited to take a look at the source code. Okay, let's go ahead and delete and download this. Let's see. So I'm on Windows. Ooh, it will take a while. Hopefully not. And then what else do we have to do? So then extract the zip file and run the executable file inside your browser. You take the files safe. When you run the gateway, it should print a logo, its version, and said listening on TCP port 9011. And then it says after running the gateway, open any project in Wowkey, go to the code editor, press F1, and select enable private Wowkey IoT gateway. Awesome. Then run the ESP project that uses Wi-Fi, and it should say client connected. Okay, so it looks like it will be up and running. My only concern is that it says the IoT gateway requires a Wowkey Club subscription. So that's my only concern. So perhaps I shouldn't even be like downloading this. Because then imagine like downloading everything and then saying like, oh, like you have to pay for using that. Let's verify that we actually don't have to pay anything. Oh, it says like private. So perhaps if we have it like public, should we be able to do it? So you'll be prompted and select enable private. You'll be prompted to enable the gateway. Oh no, I think we will actually need the private one so we can run like our own codes over there. Yes, because right now we are like on the public gateway, but then if we are like on another one, we won't be able to actually do it. Oh well, no worries. We will just go back to what we were doing. I was just trying to do like a nice example of this one, but I think we won't be able to do that because then we will have to pay like $7 per month, which I really don't want to do that. Yeah, the turns into the cloud. That will be nice. That will be nice. Great. So I will go back to the ESP32 projects that were out there to see if we can find one that actually kind of like works nicely. So let's start doing like an empty project and start connecting like some stuff so we can see how things actually work. So the first thing to be clear is that on our board we have like multiple pins like on both sides, so we can actually see them like on the actual physical device, that we have like several pins like over there. And then each pin has like a different like naming tag over there. I'm going to try to zoom in this. I think it's zooming in like the whole page, and I don't like that. But well, over here we have the 3.3, which is just basically for giving it voltage. Then we have like the 5V, and we also have the ground connection. And then we also have like other important pins, such as like the serial collection with RX and TX. And then we have like some other various pins over here that are like pin 34, pin 35, and so on. So in our case, we can just try running like the simple example, which is this one, which will just typing like a hello ESP 32. And that's just basically like the simplest thing that we can do over there. So now what we can actually do is to start, we can try connecting just like a simple LED to see how it will actually work. We can do like a blinking LED, or we can just like first connect it and then actually see how we get that running. So I would stop this, and how can I make this? Okay. And then I will try to connect like all of the things that we actually need for our LED. So the first thing that we can do before we actually like connect anything is that we can try using the built-in LED that it's on our microcontroller, so we can see if it will actually be successful once we connect a LED. So to do that, on our void setup, we need to add the declaration of the pin that we actually want to use. So to do that, we're going to use pin mode, and then pin mode actually receives two things. So the first one is the pin number where the LED is actually connected, or where our component is actually connected. And then the second thing that it receives is whether that pin is an input or an output. In this case, the LED will be an output because we will actually be outputting like the color of the LED, so it will be like an output signal. So let's type LED built in, and then we're going to use this as an output. So now that actually like seeing this, like the pin mode, telling the number of the pin and the output that we want it to be an output, I know it might seem like super simple in Arduino, or like, yes, like in Arduino language, that you just basically place like the number of the pin and like that you want it to be like an output signal. But like understanding how it actually works and all of the things that are behind that logic, it's like much more interesting that you could imagine. So over here, if you I would actually like to configure that pin in like a low level language, such as like C or like assembly language, then I would actually have to go into the documentation for my ESP32 board and tell it in which address I want to place my pin. And that address is just basically like a series of zeros and ones in like binary language. So depending on the combination that you have of zeros and ones is the specific configuration that your pin, or like or like your output pin will basically have. Just give me a moment so I can shut my door, because I think my dog is barking a little bit loud. Great. So let's continue to making our built-in LED blink. So now that we declared where we want our pin to be, now on the loop, we can actually make it like turn on. So to just make it turn on, you can just do a digital write method. And we are using the digital write because a LED basically follows a digital signal. What I mean by that is that a digital signal is just basically like a 0 or 1. So your digital signal will look something like just like squares like this that are like 0 or 1, and you will have like the rising edge, and then you will have like an ending edge. So if I were to use like another sensor, like for example, like a temperature sensor, then I might be using like analog signals, because then I will be getting a result values that are not only like 0 and 1, because my temperature sensor can read values like, I don't know, like 35 degrees, 32 degrees, and those are like analog signals who are like kind of like smooth and don't follow like any like rising clock edge signal pattern like the digital signal. So after doing the digital write, we're going to pass on the pin of the LED that we actually want to turn on, which in this case is LED built-in. And then we are going to tell it that we want it to be like high. And high just basically means that we are sending like a 1. So 1 in binary is just like activating, which is kind of like true or high or whatever you want to see that. And then I will delete this because we just want the LED to turn on for now. So let's see if it actually turns on. It's taking a while. Their queue is busy. Hey, good morning there. It's actually night for me. It's like 7. Well, not night. It's like 7 p.m. here, but it's actually like getting dark now. Wow, this is taking a much longer than expected. But that makes sense. I've run like more it would generate like more. I've done like more complex projects, and it actually takes like a really long time to complicate. Oh, someone says it will generate an error. Oh, where's the error? I'm not seeing anything. Perhaps I'm missing something. If you want to comment the error, I will for sure take a look on that. I mean, I don't think it's related to the delay that I just deleted, but I might want to add it. So now it's taking more than expected, and that's way more than I was expecting. Unknown build error. What? Why? Was it a delay? That would be like super weird. Because I literally run it like few seconds ago, and it was like literally running. That's why. I don't know if it was a delay. I don't think so. Let built-in function void setup was, oh yeah, we didn't declare where the LED built-in is. I thought it would actually automatically like detect like the LED built-in function that we have in here, but if not, we can define it ourselves. So let built-in, and I think per default is 2. Let's try with 2 to see if that will actually get something running. Because there's like on your physical board, you don't actually need to do this, but let's see. Let's try running it again. Let built-in, was it not called? Oh, it doesn't have, I need to delete this. There we go. Paint mode LED built-in. Oh, there it is. It was actually pin number 2. So now we can actually see the little red LED turning on over there, which will basically make it work. So now that we know that this actually works like for our built-in LED, we can try plugging in like an actual LED to see how it will work. So I will make this smaller. I don't know how to actually make this smaller. Let's see. Oh, just with the minus? No. Well, zoom out, zoom out, zoom out, zoom out, zoom out, zoom out. There we go. So I will add a new component, and this component is basically going to be a breadboard. because we want to connect like all of our components. Or, well, we can just try adding them directly. So I'm just going to grab an LED, and then I'm going to plug in the negative leg of the LED into the GND, which is just basically ground. Here it is. So we have connected this to ground, and I'm just going to change the color of this to black, so we know that that one is ground. Then I'm just going to basically grab like a resistor. It can be 250K. And then I'm basically going to be plugging this resistor into my LED. And then this one, I'm going to plug it to any digital pin of our choice, which in this case will be 27 because it's the one that I have the closest to. So once we have that, we can change our LED variable. So we can just call it LED pin. And then this LED pin is 27. So let me just type 27 over here. And now we can actually just change this to LED pin, and LED pin over here as well. And this will hopefully turn on our LED. Let's make our LED purple. I've never seen a purple LED like in real life. Like I've seen those like RGB LEDs that are kind of like you can turn them on in like any color, but not like this one. And now we have our LED turning on over there. And what you can also do is that you can basically make it blink just by adding like constant like on and off functions, which will be like low. And then you can add like another delay. And then that will basically make it repeat itself. And let's make this 100 so we can see a more notable delay. And then if I run this again, it will start like kind of like blinking. Yeah, there it is. It's kind of like blinking, not too slow. So let me try adding like more to the delay to see if we can actually get it running. Yeah. So that's just basically like the LED, and then I will try to connect like the ultrasonic sensor, and I will explain you how to connect that one so we can also code it as well. Look, so now the delay it's kind of like of 1 second, so it like turns on and turns off. Awesome. So let me pause this so we can add our new component. So the new component that we're going to add, it's called an ultrasonic sensor. So the ultrasonic sensor, it's basically, let's see if I have one over here. It's this one. So it's this one over here. And the thing with these googly eyes is that they basically detect like like they send like an ultrasonic ray, and it detects like the bouncing of the ray when it hits like an object. So that's why you can actually measure distance depending on the time that it's spent like going like in one direction and then going back to like the eyes of the ultrasonic sensor. And if you can see, this sensor has basically like four LEDs, four legs, I'm sorry, and it has like the ground leg, it has like the voltage LED, and then it has like the echo and trick pins, which are two digital pins that will help us read this all of this information from our sensor. So we're going to see if we can actually connect this into our circuit. So the first thing that we need to do is to actually add our ultrasonic component over here. So it's this one, ultrasonic distance sensor. So let's just grab one and put it on the side over here. So by now, I don't actually have the need to use another breadboard because I have another ground over here, and I also have another 5B over here, and I have more digital pins on this side. So first things first, we're going to connect the ground one. So the ground one will go all the way. Let me actually put this a little bit upper. So ground one will be connected over here. Then the BCC, we will connect it to the 5B that are, where is the 5B? So 5B are over here. So let me grab a cable in here and bring it up over here to the 5B. And then we have two pins, and the pins we can connect them in like any slot available that we have over here. So for example, the trick pin, I can connect it to 19, and then the echo pin, I can connect that into the 18 pin over here. So once we have our ultrasonic sensor connected, we can actually start writing our code over here. So the first thing that we need to do is to actually declare like the pins as we did over here with the LED pin. So we can add another define, and then we can call it like trick pin over here, and our trick pin in our case is 19. So we have 19, and then we can define our second pin, and our second pin it's our echo pin. And that echo pin in our case is 18. There we go. So after having that, we can now declare our pin modes over here. So we can either declare them like as an input or as an output. So I'm just going to do it below the LED pin, and I'm going to type in pin mode again. And this time I will pass first the trick pin. So the trick pin in our case will be, oh, I think I wrote it like a tree pin. So trick pin. So the trick pin in our case will be of output, and then our echo pin will be of input, because we will be reading the code that it generates. So echo pin, and then this will be input. Great. So now we have all of our pins declared, and the second thing that we need to do is to actually do like our functions over here. So the first thing that we are going to do is to send like an initial signal, and let me actually do this below here. So we can do this over here, and I'm going to write, I'm going to do a digital write, and then I'm going to pass on the trick pin, and this will be a low signal. And then the next thing that we're going to do is that we're going to add just a little delay, so we have time to receive the signal back. And I can do like 3, or it can be like 5, just like a small, super small number. And then I'm going to turn this into high, because we are basically sending our signal. So now this will be high, just like the LED. So we just send it and we get it back. And then we can add another delay over here, but one that is a little bit longer, so like 10 perhaps. And then the second thing that we will be doing is to actually do another digital write, but this time we will be reading the pulsation that is coming into our in. So to do that, we're going to create a variable that will be called duration, and duration is just basically going to be how long it takes my pulse to come and like return. So let me declare a variable in here that will be long duration. And now I can use it over here. So duration will be equal to pulse in, because we want to read the pulse of the ultrasonic sensor. And then I can use the echo pin that I declared before. And this one, I want it to be high. There we go. And then the second thing that we're going to do is that once we have the time, we can actually convert the time into distance. So I would need a new variable that will be called distance in centimeters. So let me actually create a new variable over here that will be long distance centimeters. And that variable over here would just be the duration multiplied by a constant. These constants will be 0.034. And then we actually need to divide this by 2. So this is just a constant. You can actually get it like on the internet if you search how to do this. And so once you get that, we can actually print the distance that we are getting from our ultrasonic sensor. So to do that, we can just do like a serial print, just like it was over here. So we can do serial dot print, and then we can add like distance is, and then we just add the distance over here, distance centimeter. There we go. So hopefully this will get it running. So we are declaring our LED over here, and then we are triggering our ultrasonic sensor. So this one will turn on LED on and off, and then this one will send a pulse to ultrasonic sensor to fetch distance. There we go. Awesome. So now let's try run these to see if we actually get an error. And now I'm wondering, how would the ultrasonic sensor like detect something if I cannot put my hand in there? I'm just curious about that. Perhaps if you like hover or like with the mouse, it will like detect something. I'm not sure. Let's see. Oh, my dog is here. Great. Great sis, great sis. Great. So, your part compilation is taking longer than expected. Really? I don't really want to do that. It's saying that it's like too heavy, and it's literally not too heavy. It's just like two things. I'm going to share this project with you as well. Simple hardware project. Global Hub Week, and then API. So you can actually have access to this one as well. Let me share it with you. There it is. So in case you want to see like the project, you can also access it there. Let me run it again, hoping it will run successfully. And if not, then I will try deleting like the LED logic to see if like that's it. But it doesn't make sense because I've done like more heavier projects in there. Perhaps just like their servers are busy or something, and that's why it's not like running properly. Honestly, I'm not sure. But yes, after running that, we're basically just going to create some methods on our Python code that I showed earlier. So we can kind of like simulate if that was like the sensor data that we're getting like from our Wowkey project. Oh, there it is. Distance is, yeah, it's not, oh, now I can actually tell it like the distance. Huh. And it's not printing anything. That's weird. What if I try like increasing this? Let's go through our code again to see if we missed something over there. So we declare our trick pin, and the trick pin needs to be an output, that is for sure. Then we have the echo pin, and the echo pin needs to be an input, that is also true. And this is working. Then we are sending our digital write with our trick pin, and that's low. Then adding a small delay. Then digital pin, that has to be high for the trick pin again. Oh, and then I think perhaps we need to add like another one. Perhaps the delay it's like too much, so I will try deleting the delay to see if that is, or perhaps adding like a delay but in microseconds, like a super small delay. And this one I will also change it to delay microseconds. Perhaps like the delay it's being like too much for it, that it's not like actually like generating anything. And then I can try turning this off again to see if that's causing like some error logic over there. And I think that should be it. Perhaps adding a nice delay over here as well. Let's see. So one annotation about this, and I will explain it while I run this again. So something to note, and it's quite important when working with hardware projects that I have experienced like in real life, is that when you actually use this delay microseconds or delay, this literally like shuts down all of the logic that's going on in your microcontroller. And the correct way to do that is to actually measure like the time elapsed using a millisecond instead of using the delay, because the delay is just like literally pausing like all of the processes that you have in your like in your in your environment. And in our case, like we don't care because we just have like simple things running. But if we are talking about a more like complex scenario where we are like controlling multiple systems, then it won't be like super smart to have like a delay that literally like shuts down like all of your processes just because it has like a delay. Let's see. I think it's not working. I mean, this is the correct what? End task TD in? What's that? That's super weird. It is like reading the signals that are in there. Let me try like shutting this down and then just like saving the project. I mean, this makes sense. I don't think I'm missing anything, so let's just probably try to compile it again to see if we get it working. Oh, I think it's not even recompiling. Mm, now it's not printing anything, which is even weirder. No, this is not correct. Let me try deleting like some delays to see if we can actually get it working, or perhaps this is taking like so much memory space. I mean, I don't think so. I will also try commenting like the LED logic. Well, this one, yeah, I will try commenting the LED logic, because over here we have like a 1 second delay, so that's probably like messing with the whole process over there. So we have the echo pin, which is the one that we need on high. Then we have distance in centimeters. I mean, I might double check this, but I don't think it's going to be incorrect. Let's just try printing like the direct distance. Let me save this again and start working it. So now the LED won't turn on, but that's just because I commented this to see if there was an issue in there that was just causing it to not work properly. Let's see. Well, after this, I will give it like 5 more minutes to get it working. And if it still don't work, then I will go ahead and start with the Python code, as we are running a little bit behind on time. And well, I already shared the project with you in case you actually want to see it. So now it decided to work. And yeah, I think it was because of the other logic that we had over here. So now you actually understand the importance of not using like the delays on our projects, because it's like a simple solution that you can implement when you are trying to like just try out like a single component. But once that you want like several components like working in together, then it doesn't work like very smoothly. So I'm just going to leave the digital right of the LED so it can basically be turned on. And now we're actually getting like the distance measurements over here. So distance is, and then just adding a space, and then where is it? Just so we can test this again. Oh no. Great. So that should get it working. Oh, I think it I think it stops working once I add this. Mm. I think the correct way to do this will be doing like serial print like this, and then adding like the serial print line. I think that's the correct way to go. Let's see. Let's see. Oh, I forgot to add the semicolon. There it is. Uh, let's see if we can actually get it running. Oh, so we are seeing now that apparently the concatenation over there with the plus sign was literally like screwing everything. Um, and now we're getting it properly, like distance, and then if we change the distance over here, we are getting like different measurements. Awesome. So I just saved the project and you can actually access it on the link that I just sent over on the chat. So in case like you want to add more things to it, feel free to do so as well. So now what we're going to be doing next is so we can actually continue with our sensors API, so we can perform like simple functions like in our CSV file. So let me actually open a new tab. I will go like to the same project that we were using previously. So it is this one, and now I'm just going to make this smaller. So now that we have like the definition for our API, we can just start writing like the different needs that we actually are going to be using today. So we have like the base, which is the hello world. I'm basically going to leave that so we have like a function where we can actually be debugging our code. Then what we're going to do is that we are going to be reading information from a CSV file, and that CSV file is just going to be some dummy data with like sensor values that we are going to be fetching, hopefully from our ESP32 on future instances. So the first thing that we need to do is to read from our CSV file. So in order to do that, we're going to declare a variable that is going to be called CSV file. And our CSV file, I don't know, it's going to be like something like sensors .csv. And let me actually add the declarations like on the top over here. And we're going to need to import the CSV library, import CSV. And we already have this one. And I'm also going to be importing HTTP exception so we can actually print error messages on our console once we actually need it. Then after that, I'm basically going to declare a class that will be called sensor. So we actually get like all of the information from our sensor. So I'm going to call it class sensor, and then this will be the base, where is base model? I think I need to import that as well. So from Pydantic import base model, here it is. So now we can actually use that base model, and our class will basically have, I don't know, like an ID, which will be a string. Then we can also have the name of the sensor that we want, which will be a string as well. Then we can have the value that it's actually reading, which will be a float. And I think that's for now. Yes. We also need like perhaps like the timestamp, which will be a string. So now that we have like our base model for the sensor that we're going to be initializing or reading data from, we're going to create a helper function that will help us read like from our CSV file. So this is going to be called init CSV. And then this will only like check if we actually have our file. So try, and then we're going to try opening our CSV file. So open, and then we're going to pass on the variable that we just created, which is CSV file. And then we actually need to read each line that we have. So in this case, we need to, I think it's read. So we need to read and write, which in this case will be an X. I think I did an uppercase X. There it is. And then we want to read for each new line, which will be basically empty over there. And this will be interpreted as a file There we go. And then inside our file, we actually want to start reading the different sections that we declared, which is ID, name, value, and timestamp. And we can just later generate a sample CSV file with like ChatGPT with some like dummy values, so we can just like get it running. So this will be basically write variable and then CSV dot writer, and then we are going to be writing our file. And then after that, let's use that same one again, but this one, it will be write row. And now I will be writing the values that I just declared earlier, which is ID, name, and all of that stuff. So it will be ID, then I will have name, then I will have value, and then I will have my timestamp. There it is. And in case I don't have a file found, then I will be throwing a file exists error, and I will be ending that with a pass. There it is. So now we have our file where we are going to be initializing our CSV file. And once we do that, we actually want to initialize it. So we're just going to call the function over here. So def init CSV. So this will just basically initialize our new CSV file, and we can actually try running this to see if it will be, generated. So let's try running this sample script. So let me shut this server down, and let's go to the FastAPI server. Let's shut this down as well. I think it was already, I think it created automatically when I was calling it. Oh, because the script was running, right. Okay, let me try, I will try to delete this file so you can see that when I actually run it, like it will generate like my new file. So, let me just kill this one and just do like Python and then main.py. And now it generated me like the new CSV file that has like the ID, name, value, and then timestamp. So now I have like my dummy database that I can actually like get it working. So the next thing that we are going to do is to like read the file. So to do that, I'm going to create a new function that will be called like read CSV. So let me go ahead and do that. So read CSV, and this will just basically read CSV. Well, I can call it read sensor, so we can like fake it that we are actually reading data like from a sensor. So read sensor, and again, I'm going to use this same kind of logic, but now I'm going to do like a reading mode. So to do that, I'm going to do with open, and then I'm going to open the same CSV file that we just created. And this time on mode, I'm just going to tell it that I want to read, and then I want to read this as a file. And then now we're going to call a new variable that is going to be called read. And then I want to read this as a dictionary. So dict reader, and then I'm going to pass on the file that I just opened over there. And I'm going to return this per each row. So for each row that I have, row in the read variable that we have over here. And that should do it. I mean, I can actually try, we can try testing this, but I will do it through the API instead of doing it like on my terminal. So to actually test it out, I'm going to create a new HTTP method, and this one will be a get method, which will be to read the sensor data. So app.get, and then I'm going to call it, I'm going to call it sensors. Well, sensors. And then over here, I'm just basically, you need to create a function just like we did in here with def root. But this one will be called like get sensors or whatever you want to call it. And inside this function, I would just be basically calling the other function that I created over here, which is locally. So I'm just going to return that function, which is called read sensors. So hopefully over here, we will be able to actually read information that is on our CSV file. Right now, we don't have anything. So let me ask Copilot if he can generate us like some dummy data. So generate some dummy data for ultrasonic on the CSV file. There it is. So now it's actually like it generated like some dummy data. So let me just grab this and copy paste it over here. Great. So now over here, I think my timestamp, yeah, it's a stream. So everything's good. So now hopefully when I actually, when I actually get to run this, then I will be able to be reading like this sensor data that is on my CSV file. So let's try now running actually the FastAPI server. So to do that, it was FastAPI dev main.py, which is the name of my file. So let me enter that. And then I'm going to initiate an ngrok server on port 8000. So in a new terminal, I would do ngrok http and then 8000. And now it initiated. So, oh, why can't I scroll down? Well, let me enter this link, which is where my ngrok server is actually located. And there it is. So now you are able to see it, and I'm going to click on yes, visit site. And now we can actually enter the docs to see the info. So now we have the root and we have the sensors, and let me make this bigger. So on the sensors, if I hopefully click on try out and then execute, I will be getting the list that was on my CSV file. So there it is. Now I'm actually getting like the sensor data over here from my list, which is super cool because I can actually interface with it. Great. So now that we are able to actually read from that file, I'm going to go ahead and start creating our Streamlit dashboard, as I think we only have like about 20 minutes, and I really want us to deploy this application so you can see how I'm actually using the ngrok link that it's on my local server. So I will create a new file that will be called Streamlit. Well, I'm just going to call it app, so it's faster to call. So app.py, and then I'm going to import Streamlit. If you've never used a Streamlit before, you need to install it. I think I need to install it right now. So let me just run a super quick pip install on a new terminal. So pip install Streamlit. And while it is installing, I'm going to be creating a dummy page. So to do that, I'm just going to write a title on ultrasonic sensor readings. And then I'm going to click on write. I'm going to type like I'm going to add an image in here, and I'm just going to add an image of our circuit. And then over there, I'm going to add a divider, which will be just like a line on our page. And then after that, I'm just basically going to call our function. So I'm going to do a write that will say click on the button to fetch ultrasonic data. Oh no. And then I'm just basically going to add a button over there. So if my button is pressed, which my button will be called fetch data, then what I will do is that I will call my function of my API over here that's called sensors. So to do that, I actually have to generate an HTTP request, and I'm literally not remembering that right now. So I'm just going to ask Copilot how to do that. So I'm going to delete this file. So from this, generate a get method for my ngrok API and display it. Because I think we need to import the requests library and then actually perform like the get function. Yep, this is literally all we need. So let me just copy paste this and place it here, just because we are running late in time. And now in here, I need to actually place the link to my ngrok server. So the link to my ngrok server is the one that we have over here. Oh, where is it? Let me scroll down. So it's this one that we have over here. So I can actually try copy pasting this one and then just literally pasting it over here. And my endpoint, it's not called sensors, is it? I think it's called, oh yes, it's called sensors. Awesome. So this will just basically display the JSON response over there and print if an error has actually like occurred. These are super obvious comments. Great. So let's just add an image of our circuit. So let me go back to our Wauki environment, which is over here. And let me fetch an image of this. So we can actually display it like on our dashboard. So now I have my code over here. Let me fetch that gallery. Let me just drag and drop this, and I'm going to call it where is the name? Sensor, well. And let me replace the name over here. It's called sensor. Well, it's called sense R and then PNG. And I now replace this with my image file. There we go. So now I will start running my Streamlit dashboard to see if we can actually get that running. So to run our Streamlit dashboard, I'm just going to do a Streamlit run and then the name of my file, which is app.py. And let's see if it actually fetches the data from my API. There's my image, and then let's try clicking on fetch data. Awesome, there it is. So now I'm actually getting the data that is fetched from my ultrasonic sensor through our API. And our API in this case is this one over here. So just to show you the importance of having like a hosted API, let's imagine if, for example, I shut down the server where the ngrok is running. So this one. So let's imagine that I shut this down and it's not running. So now if I go to my dashboard and I refresh this, I won't be able to fetch the data because it says that the API is not running. So in this code, we are basically testing like three different things. So we are reading from a local database, we are creating our local API, and then we're exposing that local API to a public API that we can actually access through the internet. So now what I'm going to do is that I'm going to deploy this project so you can actually have access to it in case you want to play around with your own ngrok server as well. So let me just rename this so it's not like too bad. So sensor, and then I'm going to call this over here. I'm going to create a requirements file over here so we can just install all of the dependencies that are necessary, which in our case, we are only using FastAPI and I think, and requests. But I think the request ones is not actually needed. So let me just add like FastAPI and then requests just in case. And I'm going to publish this into our GitHub repository, created simple get method in hosted API. And I'm also going to publish the CSV in case someone wants to take advantage of that and like actually see it. Now that everything is up in my repository, I can actually deploy our application from the Streamlit dashboard. So I'm going to try and deploy this. And before I deploy it, I'm going to add a new more fix that it's going to be actually running our ngrok server, because we need it, because the link changes every time that we shut it down. So let me run it again in ngrok, and then let me paste this link on our Streamlit dashboard over here. And I think something simpler to do, if I just add like a variable where the user can enter like their ngrok server in case they don't want to like change the code regularly. So I'm just going to add a new subtitle. Is it subheader? Subheader, and then enter your ngrok link. And then I'm going to add a button. No, I'm going to add a text input that will be called a variable that will be called ngrok link. And then this will be a text input. And this will say paste your ngrok link. And then I can add, can I add like a placeholder? Yeah, I can add a placeholder. And as a placeholder, I'm going to add my own ngrok link. There we go. So now instead of actually like passing it on over here, I'm just going to add it over here that will be called our ngrok link. And then I'm just going to, I think I actually need to, yeah, I think I need to format this. And then I need to add this in like the nice braces. Where is it? There it is. Is it not like that? Oh my god. Oh, I think I'm forgetting how to do stuff. Oh, I think it is. I'm sorry. I think it is over here, and then like the braces on this side. And then deleting this one. Is it not like that? Was not close. Perhaps, well, I'll just add it like by default. ngrok link, and then I'll just add it later. So ngrok link, and that should do. Data. Let me ask Copilot to format the endpoint. Can you format the endpoint? Let's see if it actually gets it. Oh, so it was like that. Okay. Now we are good to go. So now I can actually publish this, and a user would be able to add like their own ngrok link in case they don't want to like directly like modify the code. So let me add it custom. So let me publish this, and now I can actually go into the Streamlit dashboard so we can deploy our app. So where is our dashboard? It's not here. It's not here. Where is it? I think it shut it down. So let me run the app again. FastAPI dev main. And then let me shut this down and run it again. Streamlit, run app.py. There it is. And now I can actually deploy these over here. So deploy, and then I'm going to deploy it from the Streamlit community cloud. And it automatically took everything that I had over here. Also the path, which in my case is app.py, and then I'm just going to call it ESP32. Well, I'm going to call it ultrasonic viewer, and then hit on deploy. So now when I have this deployed, I can actually enter my own ngrok link, and that should be enough to be running our local server. And we can actually see the status of the page over here. So let me just prepare with my link so I can actually copy paste this on our page. So let's just give it a while for it to deploy. And if it's deployed successfully, then I will be adding that link as well on our GitHub repository so you can access it as you wish. It's taking longer than expected. And it's just basically like a simple, super simple thing. Let's see. Wow, it's taking a long, well, just yesterday I deployed another app and it didn't took so long. So that's why I don't know if it's my internet connection, but I would leave it running as we have 10 more minutes to see if I can actually get it to deploy. Now I'm genuinely concerned because it's not even showing what is it doing. It's just waiting there. Oh well. In the meantime, I'm going to check what's the next global hack week. Just so I can see oh, it's open source. And then we have a one coming up for Gen AI. I think that's the first time that we have Gen AI. This is brand new, I think. Because right now we're on APIs, and then we're going to have open source. And I think for open source it will be really cool if we could make a stream where you could make your first open source contribution to a cool project online. I will think about that because that will be fun. That will be fun. And then for Gen AI, I think there will be a lot of things coming up. What we have coming up later on. So right now we are on this one, and then at 10 p.m. you're going to be building a Pokédex using the Pokemon API. That sounds like fun, huh? Clustering algorithms. That sounds advanced. Oh, there it is. Now it published itself as after a really, really long time. So let me try pasting my ngrok link over here to see if it actually works. And then let me fetch the data. Is it not working? Let me see. Let's see why am I getting that status code. So it's not showing anything in here. It's not showing anything over here. Neither over here. Oh, not found. Perhaps. Oh, it's not. I think it's not called the endpoint's not called data. I think the endpoint it's called sensors. That's why. then let me update this to do it sensors. And there we go. Let me minor endpoint update. And the cool thing about Streamlit is that once I push into my repository, it will automatically update my app. So if I go back to my app, it looks like it is being updated. So now it just updated. So let's try to fetch the data and still getting 404. So let's see the error on my ngrok server. I hate that I cannot scroll down. Now it's saying the get sensor doesn't exist. Is this the same? Let me try with this ngrok link. Perhaps this is a bad link that it's not working. Let's see. I mean, if it works. Oh, it's sensors, not sensor. Oh my God, I had a really bad eye for this. Minor endpoint update. And well, that's the thing about manually checking like mistakes. Like you just go into the ngrok server and you check like the errors that you're getting, and then you can automatically know what your mistake is. So let me go back to the app, and now it's updated. So let me try fetching the data, and now I'm actually getting the info over here. So let me try. I will share this link with you as well, with the Streamlit as well. Oh, we have a question over here. Hello, I don't know why I'm sitting here since an hour, but it seems a good approach. Will refer for my research project as I have API dev with ESP32C3. Oh, that's nice. Yes, I mean, this was not like a complete stream focused on hardware, as we just had like 2 hours. I wanted to focus more on the part of actually like getting your ngrok server running and using like FastAPI, so you can have like your own API configured. And I just gave like some insights about how to use like an ESP32 for a simple like ultrasonic sensor. But I will for sure be taking into consideration like doing more streams where we actually focus like on hardware. And those streams, I will be giving them in like more serious, not just like a single part stream or like a part 3 stream. So we actually have time to build like all of the circuit and then implement it into Wauki, because Wauki is actually a really nice tool when trying to work with like simulated hardware. So I would definitely be doing that on the future as well. Great. So before we wrap up, I already shared with you this link on the chat, and I'm also going to publish this into our GitHub repository, so you can actually have access to it on the GitHub link. And I'm also going to share with you, just give me a moment. I'm also going to share with you a super important link that you need to have. Let me just search for it super quick. So the link that I'm going to share you on the chat is so you can write like basically your recommendations or like your feedback in general about Global Hack Week. It doesn't have to be like necessarily like for this stream. It can be like for any feedback that you might have about Global Hack Week. So thank you very much for having me, and I will see you until the next Global Hack Week, which will be for open source. So make sure to tune in over there, and have a super nice day or super nice afternoon or good night, which is that on my case. And remember that we have the next stream coming up in just like about 2 hours, which will be featuring the Pokemon API usage. Bye, everyone.